Today's honors geometry lesson is on section 5.2 proportions. The objectives are to apply the properties of proportions. Before we start the lesson, let's go ahead and look at a warm-up. So at this time, stop the video, work through the warm-up, and when you're ready to review the answers, go ahead and continue with the video. Here are the answers to the warm-up. If you have any questions, go ahead and write down the answers and come to the next class and ask those questions. So let's go ahead and continue on with today's lesson. So for proportions, each of the numbers a, b, c, and d in the following proportion of a over b equals c over d is called a term of the proportion. A is considered the first term, b is the second term, c is the third term, and d is the fourth term. When more than two ratios are equal, they are expressed as an extended proportion as follows. So we can say that a over b is equal to c over d, which is also equal to e over f, which is equal to g over h. The means extremes property in a proportion means that the first and last terms, which are called the extremes, are in red, and the middle terms, which are called the means, are in green. So whether the proportion is expressed using colons or as a fraction, A and D are always going to be your extremes, which are in red, and B and C are always going to be your means, which are in green. So the product of the extremes in red are always going to be equal to the product of the means, which are in green. So in other words, A times D will always equal B times C in any proportion. Here are some special properties of proportions. So given the proportion in red, A over B is equal to C over D, here are just a couple of the special properties of proportions. So we can say that A over C would also be equal to B over D. We could say that B over A is equal to D over C. C over A could be equal to D over B. And two other special properties. We can also take A plus B over B and set that equal to C plus D over D, or we can say A minus B over B is equal to C minus D over D. Now these are just a couple of the special properties of proportions. What I would like you to do now is to stop the video and see if you can't come up with a couple more. Using what we know about special properties of proportions, let's take a look at example 1. Complete the following statements using the proportion. X over y is equal to 4 over 5. So if we take 5 times x, we can say that that is equal to 4 times y. If we take y over x, we can say that that is equal to 5 over 4. If we have x plus y over y, we can set that equal to 4 plus 5 over 5, and 4 plus 5 would give us 9 over 5. And lastly, if we take x over 4, we can also say that that is going to be equal to y over 5. For the second example, we're going to use what we know about the means extremes property, or cross multiplication. So we know that if we take A times D, which are the extremes, they're going to equal C times B, which are the means. So for this example, if we cross multiply, we can take the quantity of x plus 2 times the quantity of x plus 2, and we can set that equal to the quantity of x plus 6 times the quantity of x minus 1. So now all we need to do is go ahead, simplify, and solve for x. So we're going to go ahead and use FOIL, first, outer, inner, last. So x squared plus 2x plus 2x plus 4 is equal to x squared minus x plus 6x minus 6. And we're going to go ahead and combine like terms on each side. So this will give us x squared plus 4x plus 4 is equal to x squared plus 5x minus 6. So now we can start simplifying using what we know about solving equations. So if we subtract x squared from both sides of the equation, we're going to be left with 4x plus 4 equals, forgot my x here, 5x minus 6. If we subtract 4x from both sides, we're going to have 4 equals x minus 6. And then lastly, if we add 6 to both sides, we're going to get an answer of 10 equals x. To see if we're correct, we can go ahead and substitute in 10 for x, and if this is true, both ratios should simplify to the same fraction. So 10 plus 2 is 12. 10 plus 6 is 16. And that should equal 10 minus 1, which is 9, over 10 plus 2, which is 12. And that is correct because 12/16 is equal to 9/12, which is the same thing as equaling 3/4. So the second example, for example number 2, is going to take us a little bit longer and it's going to require us to factor, but we're still going to set up the same way. So we're going to take x times 8x minus 6 and set that equal to 2 times 11x plus 8. And we're going to start simplifying, so we're going to distribute. This will give me 8x squared minus 6x is equal to 22x plus 16. Okay, so what we're going to do now is we're going to start moving everything over to the left-hand side so we can factor. So if we subtract 22x and subtract 16, we're going to have 8x squared minus 28x minus 16 equals 0. And when we start factoring quadratics, the first thing we want to do is factor out any greatest common factor. So if we look at 8x squared, 28x, and 16, we can factor out a 4, which will leave us with 2x squared minus 7x minus 4, and that's equal to 0. Since the coefficient in front of the x squared term is not 1, we're going to have to factor by grouping. So we're looking for two numbers that multiply to negative 8, but when you add them, multiply to negative 7. So those factors are negative 8 and a positive 1. So for right now, we're going to ignore the 4 that we factored out, and we're going to factor the quadratic. So we're going to factor by grouping. So 2x squared, we're going to rewrite the negative 7x as negative 8x plus 1x minus 4. And remember, we practiced this the other day, factor by grouping. So in this case, we're going to factor out a 2x, which will leave us with x minus 4. On this side, we're going to factor out a 1, which leaves us with x minus 4. So we know that this factors into x minus 4, 2x plus 1, and we're going to make sure we bring down the 4 right here. Okay, so now we have factored this quadratic, and if we want to solve for x, what we're going to do is we're going to take each factor that has an x in it and set it equal to 0. So x minus 4 equals 0. 2x plus 1 equals 0. So if we solve each side for x, we're going to see that one solution will give us x equals 4. And the second solution, if we subtract 1 and divide by 2, x is going to equal a negative 1/2. So for this example, we actually have two answers. So both an answer of 4 and an answer of negative 1/2 will give us the correct value to make these two fractions or proportions equal to each other. This is the end of lesson 5.2. If you have any questions, feel free to watch the video for a second time. And if you still have questions, write down any clarification questions you may have and please bring them to the next class.